Greetings. In this video, we're going to look at the connections between a table, pattern, graph, and equation. So let's start with our tile pattern. So let's say these are figures 0, 1, and 2. So the very first thing we want to do is we want to understand this pattern. Okay, where are we adding tiles? How is this pattern growing? Well, I see that from figure 0 to figure 1, we're adding these two and this one. And that's the same to get from figure 1 to figure 2. So we're adding 2 tiles on the left and 1 tile on the right. So we're adding 3 tiles each time. So if I want to draw figure 3, I'm just going to add another column on the left. So I added these two. I'm just going to have 3 across the bottom because I added this one. So here's figure 3. And we see from this tile pattern that we are adding 3 tiles each time as we go through. So now we want to turn this into a table. Okay, so we're going to make our typical XY table, where X represents our figure number and Y represents our number of tiles. So we're going to have figure 0, figure 1, figure 2, figure 3, and figure 4. So now we're just counting. Figure 0 has 2 tiles. Figure 1 has 5 tiles. Figure 2 has 2, 4, 6, 8 tiles. Figure 3 has 11. Now we know from our pattern, we realize that we're adding 3 tiles each time. So we know that figure 4 is going to have 3 more. We're just going to keep adding 3. And figure 4 is going to have 14 tiles. We do the same thing. Let's go to figure 5. Well, we're going to add 3 more tiles again. This is going to have 17 tiles. Okay. And figure 6, 20, because we're just adding 3 tiles each time. That's what this means. We're adding 3 tiles each figure. We call this our growth. That's how this tile pattern is growing. We're adding 3 tiles each figure. Up here, we see that we're adding 3 tiles each figure. Okay, now let's look at a graph. Okay, now let's graph this tile pattern. So for right now, we're just going to concern ourselves with a 1-quadrant graph, even though we do understand now that tile patterns can be represented in a 4-quadrant graph. So our x-axis again is still the figure number, and our y-axis is still the number of tiles. So we're just including our scales. Okay, so figure 0 stays on our y-axis, so figure 0 has 2 tiles. Okay, then figure 1 has 5 tiles. Figure 2 has 8 tiles. Figure 3 has 11 tiles. So now we're going to draw our line through these points. Arrows on both ends. So here's our graph for this tile pattern. Now we want to make sure we understand what growth looks like in a graph. So we want to see, as we saw in the book, we see these what are called growth triangles. Now what these mean is, as we go from figure 1 to figure 2, as we go over one figure, we're adding 1, 2, 3 tiles. That's what this growth triangle means. Whenever you see this growth triangle, it means as you go over one figure, we're adding 3 tiles. Okay, and that's the same throughout. over one figure, adding 1, 2, 3 tiles, over one figure, adding 1, 2, 3 tiles, over one figure, adding 1, 2, 3 tiles. And this pattern of over one figure, up 3 tiles is going to stay the same throughout the course of this line. So this is how we graph our tile patterns, or this is how the graph looks like for this tile pattern. Now we want to understand is how can we write the equation? Okay, we learned some shortcuts with our silent board game, and we're getting better at guessing and checking, but there shouldn't be any guessing and checking anymore. We understand the connections between a table, graph, and the tile pattern, so now we want to understand, well, how can we turn this into a rule, turn this into an equation? So let's first think about how many tiles are going to be in figure 100. Now if we see, we know we're adding 3 tiles every single time. We're adding 3 tiles each figure. So to get from figure 0 to figure 5, we're adding 3 tiles 1, 2, 3, 4, 5 times. To get to figure 6, we're adding 3, 1, 2, 3, 4, 5, 6 times. To get to figure 7, we would add 3, 7 times. So to get to figure 100, we would just add 3 100 times because we're adding 3 tiles each time. Well, we know back from elementary school that adding 3 100 times is simply 3 times 100. We're adding 3 100 times. So eventually we're going to add 300. Now we want to think, what are we adding 3 to? Well, we're starting with 2 tiles in figure 0. We're adding 3 so many times to what we start with. We're adding 3 100 times to our 2 tiles in figure 0. So we're adding this 3 100 times to 2. So figure 100 would have 302 tiles. Okay, let's think about figure 50. What would figure 50 have? But the same idea still holds. We're continuously adding 3. We keep adding 3. Okay, so to get to figure 50, we're going to add 3 50 times. And that's just 3 times 50. And we're still adding 3 to our original 2. This is our 2 tiles in figure 0. Okay, that's what we keep adding it to. We're adding it to our 2 original tiles in figure 0. So figure 50 is going to have 152 tiles. And no matter what figure number I pick, even if I pick a weird one like figure number 4193, well, I'm adding 3 4,193 times, and I'm still adding this to 2. And regardless of what this equals, we want to understand our process. We're doing 3 times our figure number, because this is how many times we're adding 3. We're adding 3 because we're adding 3 tiles each time to whatever figure number we pick, and then we add 2. So even if we pick figure number 17, we're adding 3 17 times, and we're still adding it to our original 2 tiles. So what if figure x? Well, the same thing holds. X just represents whatever figure number I tell you. So if I tell you figure 17, we're doing 3 times 17. If I tell you figure number 4193, we're doing 3 times 4193. So whatever figure number I tell you, we're going to multiply it by 3, because that's how many times we're adding 3, and we're adding 3 to the original 2. So our rule is just this. Y is the number of tiles, equals 3 times x plus 2, where this 3 is our growth, which is the number of tiles we're adding each time, and this 2 is what we're starting with, the number of tiles in figure 0. Okay, it's what we're adding our 3 tiles to. Okay, so our growth is what we multiply by our x, because that's what we keep adding each time. And we're adding it to the number of tiles in figure 0. So this is the connection between a pattern, an original pattern, our table, our graph, and our equation. This equation is very important because once we understand this equation, we can make graphs better, we can make tables better, and we could jump right to writing our equation, because these are the only 2 things we need. We need the number of tiles we're adding each figure and the number of tiles in figure 0.